general relativity, step by step. I've spent a long time talking about tidal forces, and I've derived this Riemann tensor, sometimes Riemann-Christoffel tensor, which gives me the tidal forces on a bunch of free particles in a curved space. And it took some considerable algebra, as you can see if I can scroll back across the all that algebra we had to do. If you cast your mind back to screencast 58, a long time ago now, I wrote the following equation down. I had VA semicolon BC minus VA semicolon CB equals R D ABC VD. And you'll remember that VA semicolon B was the covariant derivative, which was equal to di VA by di XB minus Christoffel CAB VC, I think. Yeah, that's right. And I was making the observation that if one swapped the order of differentiation, see here it's BC and here it's CB, then the result was not the same in a non-flat space. And I was talking about things like parallel transport and so forth. Now, the reason I mention it is this object here. You'll notice I'm using ABCD here. That was because this thing here is a mathematical object, mathematics, to do with manifold differentiation and working with vector fields on manifolds. This thing here is very, very clearly, this thing here is physics. Because we're talking about tidal forces, we're talking about four-dimensional space, we're talking about geodesics and so forth. We're talking very clearly about physics. The thing that's surprising is that it's actually the same object. Well, you can see it's the same object because the derivation here comes out with the same definition as we had back in screencast 58 and previous screencasts. So we now, at long last, have a link between the physics of space-time and the mathematics of space-time. And Einstein used this connection, or used this identification, to be able to link the worlds of physics and the worlds of mathematics together. And he did so in the field equations, which we'll cover next. But it's a rather, I won't say mysterious, but it's a deep, deep thing that these two objects here are in fact the same thing, or they've got the same representation. And it's that deep connection that Albert Einstein used in the field equations, which I'll talk about next, I guess. Stop there. Stop.